All right, so welcome to 9.6. We're going to take powers to a powers and also do that in reverse. We're going to do square roots with powers. So let's see this. So we have 2 squared, which is 4. Now 2 squared cubed, that whole thing cubed would be therefore 4 times 4 times 4, right? Because we said 2 squared was 4. So 4 times 4 is 16, and 16 times 4 is 64. And 2 cubed is 2 times 2 times 2, 8. So 2 cubed squared would be 8 squared, also 64. All right. And 2 to the 6th would be 2 times 2 times 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is also 64. So what's this all about? Well, that's 2 to the 6th. Well, 2 cubed squared is also 2 cubed times 2 cubed. That's also 2 to the 6th, right? 2 cubed squared is 2 cubed times 2 cubed to the 6th. So it also must be 64. And 2 squared cubed is 2 squared times 2 squared times 2 squared, which is also 2 to the 6th, right? Numbers 2, 4, and 5 were all 2 to the 6th. Now, so x squared cubed is x squared times x squared times x squared is x to the 6th. Y to the negative 5th squared is y to the negative 5th times y to the negative 5th, which is y to the negative 10th, which is 1 over y to the 10th, right? Because you can't leave the negative exponent. So write these out like this, and they're a piece of cake. All right, so let's do this. This is x to the 7th times x to the 7th, which is x to the 14th. Right? This is 8 cubed. We're treating that 8 we're simplifying, not evaluating like the warm-up. So it's 8 cubed times 8 cubed, which is 8 to the 6th, right? Don't multiply those 8. They're not coefficients. They're bases of a power. All right, so this is 7x to the 6th times 7x to the 6th, which is, now those are coefficients, so they actually get multiplied, and then 49x to the 12th. And this is negative 5xy to the 4th times negative 5xy to the 4th, which is positive 25x squared y to the 8th. Now, some of you hopefully are noticing there is a shortcut here where you could multiply these exponents. I have taught that in the past, and it turns out not to work out well because there's too many rules. There's the ones where you're adding, there are ones where you're subtracting, and then now there'd be ones where you're multiplying. I don't recommend using that. I recommend actually writing out the problem and just doing what you already know how to do, which is add the exponents and multiply coefficients. All right, so this is 9x squared y cubed squared, right? Which is 9x squared y cubed times 9x squared y cubed, which is 81 x to the 4th y to the 6th. That's the area of that square. This is 12 times x to the negative 3rd times 12 times x to the negative 3rd, which is 144 x to the negative 6th. Can't leave that negative exponent, got to bring it down here and make it x to the 6th. This is negative 9x to the 4th y to the negative 1st times negative 9x to the 4th y to the negative 1st. Negative 9 times negative 9, positive 81, x to the 4th times x to the 4th, x to the 8th, y to the negative 1st times y to the negative 1st, negative 1 plus negative 1, negative 2, can't leave that, 81 x to the 8th over y squared. All right, this works with scientific notation. This is 2 times 10 to the negative 3rd times 2 times 10 to the negative 3rd, which is 4 times 10 to the negative 6th. And you're allowed to leave that negative exponent because this is scientific notation, right? And that's not x, that's the multiplication symbol. All right, so now we're going to do that in reverse. Now we have to assume, to do it in reverse, we have to assume x is a positive, all right? If you have the square root of a negative number, you get something called an imaginary number. And we're going to save most of that for high school, but notice we've never had a negative number in here when we did a square root. It was always a positive number, okay? We could have square root of 0 is 0. All right, then variable square roots are just the reverse of the variable squared. So let's look at this. So the square root of x squared, those cancel each other out, you get x. Square root of y to the 10th, right? Oops, my bad. All right, the square root of x squared is x. Square root of y to the 10th is y to the 5th. Why? Well, think about this. Y to the 5th squared is y to the 10th. So the square root of that, right? Let's write this. Y to the 5th squared is y to the 10th. So the square root of that is back to y to the 5th. All right, so let's see that. The square root of x to the 6th is x cubed. All right, why is that? Because x cubed times x cubed is x to the 6th, right? You add you don't add x to the 9th, it's add the exponents. Square root of x to the 12th, that's x to the 6th. X to the 6th times x to the 6th, or x to the 6th squared, is x to the 12th. So this must be y to the 9th. So what's the pattern? Yes, you're dividing the exponent by 2 here, but really it's y to the 9th squared backwards. Okay. All right, so you're going to take the square, so this equals the square root of 49 times the square root of x to the 6th. Now you don't have to write it out that way, but this equals 7x cubed, right? The square root of x to the 6th is x cubed, the square root of 49, 7x cubed. So the square root of 25 is 5. The square root of x to the 16th is 8, not 4, right? Because x to the 8th squared is x to the 16th. Be careful on ones like that. Y to the 10th. All right, so what does the sides of the squares have to be? Well, they have to be the same because it says the square, and it should be 6. So we need to do the square root of that, and 6x cubed y to the 5th. That's what both these sides are, right? And if you're not sure, right, realize that you can check your work, right? 6x cubed y to the 5th squared, right, equals 36, x to the 6th, y to the 10th. Right? Now, here is the shortcut, right? So there are times when it's useful, like right there. But this, right, why is that useful? Because you don't want to write 9 squared 7 times, right? So in this case, you're like, oh, I don't want to do that. I agree with you. 3, 6, 7, right? That's 9 to the 14th. Right? So this, you don't want to write this out, x to the 15th, y to the 10th. There's a 1 there, right? So z to the 5th. All right, now this is a little trickier. All right, so it is x to the negative 20th, which is 1 over x to the 20th. Yeah. Right, so these were 3 where, yeah, using the shortcut of multiplying the exponents might be helpful. But I'd say on the regular basis, write them out unless they're really, really long. Right, and by the way, you could have also written this as 1 over x to the 5th to the 4th. Notice you get the same answer. Negative exponents make reciprocals. Right, coefficients have an exponent of 1, right? So, you know, let's think about this. 2x squared y times 2x squared y times 2x squared y is 8, right? So this is, you're multiplying, right? So this was, just so you know, this was 2 cubed, right? X to the 6th, y cubed, which becomes 8x to the 6th, y cubed. Okay, so this is 2 cubed, x to the negative 12, y to the negative 6. So that becomes 8. Then the others flip down here and become x to the 12th over y to the 6th. All right, so this is 11 to the negative 2nd times y to the negative 2nd, because both of these have 1s. All right, so they're both going to go down to the denominator and do that. And so this is 1 over 121y squared. This is 5 to the negative 2nd, x to the positive 8. Negative 4 times negative 2. All right, so the x to the 8th stays where it is, and that becomes 5 squared down there, which is x to the 8th over 25. Yeah. Now remember I always say the coefficients don't flip, but the coefficient does flip here because of these parentheses, right? This is a good time to talk about that, right? This is equal to that because the coefficient flips because now the coefficient is in the parentheses. It's part of the base, right? This coefficient is also, because of the parentheses, is part of the base. And notice that that becomes a -8 and you still end up with the same answer. All right, there's another question mark problem. The question mark's on y, so all we have to do is, well, all right, so let's do this. I'm going to write it out. So -4 squared, +16, x squared times 2, x to the 4th. So what does the question mark have to be? I think the question mark has to be a 4, right? In other words, to make that an 8, right, you would have to have a 4 times 2, 8. All right, so let's practice. All right, so this is 11 squared, x squared, y to the 6th, or 121 x squared, y to the 6th. This is 4 cubed, x to the 15th, y to the -6th. 4 cubed, 4 times 4 is 16, is 64 x to the 15th. But the y comes down here and becomes y to the 6th. This is 2 to the -3rd, x to the -15, y to the +6. So this comes down here, this comes down here, and the y to the 6th stays, right? So we get y to the 6th over 8 x to the 15th. Square root of 81 is 9. Square root of x to the 4th is x squared. Square root of y squared is y. That's 9x squared y. And again, if you're not sure if that's the square root, multiply it times itself. Does it make what we started with? Sure does. That's the square root of 81x to the 4th y squared. Final question. Oh, I have scientific notation for my two sides. So this is 2 times 10 to the 5th squared. I should write that a little neater. And that is 2 times 10 to the 5th times 2 times 10 to the 5th is 4 times 10 to the 10th. Good luck with our homework.